right then, yes, so thank you very much. So I gather that I have a whole hour, but I'm only going to speak for at most half an hour so that we have plenty of time for questions. Miguel tells me that you are a very interactive audience, which is what I like, so that's great. And what I'm going to try to do is, first of all, give you a bit of background about aging, about the right way to think about aging, in particular about why some of the more popular ways that people think about aging are biologically incorrect. And from there, I will move on to talking about how we are in the process of bringing aging under medical control. Then towards the end of the talk, I will discuss a bit about where we are in that process and how the world is beginning to wake up to this. And I think I'm going to finish by some comments about how this relates to the current pandemic. I don't have any slides about that, but I do have a number of things to say. So I will get onto that at the end. All right, so we all know that over time the population gets older. In other words, people survive for longer and the proportion of the population over a given age goes up. So this graph is just for illustration. It's from the US, but you would get more or less the same graph for any industrialized country. The proportion of people over the age of 65 going up from under 10% in 1900 to over 20% in 2100. And of course, that has an enormous economic impact. On the one hand, it's a good thing that more people are staying alive to in a good state of health so that they can contribute to society. But on the other hand, the problem is that when people live a long time, they still get sick, and yet they get sick from types of problem that last for a very long time. Whereas 200 years ago, when a lot of people used to die in infancy or in childbirth, they would go from being completely healthy to being dead in no time at all. So that, of course, means that the cost, the actual cost in monetary terms of the health of people's health today is much greater than before. That's what this graph is showing. Again, I'm using statistics from the United States, but again, it would be just the same in Spain or in any other country. The red line is what had happened to the size of the US economy over a 50-year period, starting in 1960 through to 2010. And the blue line is what's happened to the expenditure on medical care in the US during that same interval. As you can see, you know, they both go up, but it doesn't look particularly scary. But then it looks terrifying when you divide one by the other. That's the green line, which is the proportion of the US economy that is spent on medical care. In just 50 years, gone up from 5% to 18%. And this, of course, is why everyone thinks that the economy is going to go downhill and we're going to, the Social Security is going to go bankrupt and so on. So what's the problem here? Well, of course, the problem is not this graph. The problem is not having a lot of people over the age of 65. The problem is this graph, which arises from the fact that those people are increasingly sick. If we could arrange so as to have medicine that really works to keep people who were born a long time ago, nevertheless, just as healthy, both mentally and physically, as they are when they are young adults, then this wouldn't happen. And we wouldn't see aging as a problem, as an economic problem. So to put that another way, let me say this. We don't work on longevity at Sense Research Foundation. Nobody who works on the biology of aging really works on longevity at all. If you read about me in the newspapers or see me on television or whatever, then you will often see people say that I work on immortality, or at least on extreme longevity. But that's absolutely not true. It's just done because it's in order to be sensationalist and sell papers. What I actually work on is health. I am interested in keeping people healthy. And yes, that will mean probably that people live a lot longer on average. But that increased longevity is just a side effect. I think it's a great side effect. It's an excellent thing, but it's just a side effect. So what we actually work on is health. So now, aging. Well, let us ask ourselves, first of all, this very simple question. So simple that most people have forgotten to ask it. And that's a bad thing. It helps to ask it. The question is, why are people still getting sick? If we've been so successful with really simple medical measures, even just like, more hygiene and simple medicines like vaccines, if we've been so successful in almost eliminating the kinds of diseases that made people sick and killed them at a young age, in infancy or early, a long time ago, why have those same medicines been so unsuccessful against the diseases we see in late life? That's a really important question. And I believe the main reason why most people don't bother to ask that question is that they think they already know the answer. They think it's just this, that the problem is simply complexity, that so many things go wrong with us late in life. And of course, they go wrong more or less at the same time, so they interact with each other, and it makes it even more complicated. Now, of course, that is true, and that is part of the reason why the health problems of late life are more difficult to address than the health problems of early life. But it's actually not the main reason. And in order to introduce the main reason, what I'm going to have to start with is telling you what aging is. All right, now, first of all, it's insane. It's ridiculous that I have to tell you what aging is. Because let's face it, aging has been the #1 preoccupation of humanity since the beginning of civilization. So you would have kind of thought that people would have figured out an agreed definition of aging, but they haven't. If you ask 10 people what aging is, you'll get 10 different answers. It's not good. And if we don't agree about what aging is, we can't have a proper conversation about it. But it's more than that. This definition that I'm using here is not just for the purpose of making sure that we're all on the same page. The main purpose of this definition is to demystify aging, to help you understand that aging is not some enigma that's poorly understood. We actually have a pretty good understanding of what aging is. So here it is. Aging is the combination of two processes. There's a process on the left where our metabolism generates damage. So our metabolism is simply the entire network of processes that keeps alive from one day to the next, starting at the beginning of life. And damage is defined as changes to the molecular and cellular structure of the body that occur as intrinsic, unavoidable consequences of metabolism. Okay, so that means that damage accumulates in the body throughout life. The reason we call it damage, the reason why that's an appropriate word, is because of the right-hand process. The body is set up to tolerate a certain amount of damage, right? But only a certain amount. So eventually there's more damage than that, and that's when the body starts to work less well. That's what we call the pathologies of late life. Our mental function and our physical function decline as a result of having more damage than the body is built to tolerate. That's all that aging is, the combination of those two processes. And you may have noticed that that definition could equally be used for the aging of a simple man-made machine, like a car, for example. It could be damage is things like rust. Rust happens as a consequence of the normal functioning of a car. And it starts from the day the car is taken out on the road for the first time. But you don't have to get rid of the rust of a car for a long while because the car is built to tolerate a bit of it. So what do we do these days against aging? Well, basically what we do is geriatric medicine. We wait until people get sick, and then we try to eliminate the pathologies of late life directly. Now, you can just look immediately at this simple definition of aging and see that that's ridiculous, that there's no way that that could ever work. Because look, the pathologies of late life are consequences of something that's accumulating, which means that clearly anything that falls under the heading of geriatric medicine is going to become progressively less effective as the person gets older and they accumulate more damage. I mean, it's just obvious. So the question really is, why have we stuck to this? Why has the medical profession continued to try their best to make geriatric medicine work when it obviously can't? One answer might be, well, they couldn't think of an alternative. And yeah, well, I mean, I'll show you why that's wrong in a moment. But I think another reason is that people have been confused about what aging is. I gave you a definition of aging earlier, and I explained how bad it was that people are confused about that definition. So here's a bit more about that. Here's what most people would say if you were to ask them the question, in what ways can somebody be sick? They would say, well, let's see, there are infections, that's column 1, communicable diseases. Then there are genetic diseases, congenital things, which people inherit from their parents if they're very unlucky, that's column 2. And then there's the big one, the chronic, progressive diseases of late life, like Alzheimer's and almost all cancers and, osteoporosis, all those things that I put up in really small font earlier on. And then most people would say that way out in the stratosphere, there's this other category of ways to be sick that's completely different from diseases, and it's called aging itself. And it consists of these rather poorly defined things like frailty. Now, the thing is, that definition, that classification of ways to be sick sounds good, but it's completely wrong in one absolutely critical way. This is the way. That big, thick black line is in the wrong place. This is the correct way to classify ways to be sick. And as you can see, all of the columns are identical. They're the same as they were last time, but that black line is in a different place. And that emphasizes two things. The first thing it emphasizes is that column 3 is nothing like column 1, right? And that's something I've told you already, that there's no reason whatsoever to believe that we would be able to succeed in curing the things in column 3 using the same kind of medicine that works in column 1 so well. But the other thing that this does by moving the black line is it says something even more important, which is that there is absolutely no meaningful difference between column 3 and column 4. The only difference is semantic. The things in column 3 are the aspects of aging that we've chosen to give disease-like names to, and the ones in column 4 are the ones we haven't. That's all. And if we take that into account, it becomes easier to see that we do have alternatives to geriatric medicine. Now, I'm not the first person to realize everything I've told you so far. In fact, more than 100 years ago, a few people started to understand it. And that's where the whole field of gerontology came from. Gerontology is the study of the biology of aging. And it was inspired by looking at the natural world and seeing that some species live a lot longer than others. In particular, some species seem to just accumulate damage more slowly than others. So the idea was, well, hey, maybe if we study that variation really hard, really hard, then eventually we'll understand what's going on well enough so that we can implement it medically. In other words, we can take people and somehow make their metabolism run more cleanly so that it generates damage more slowly than it normally would. If you can do that, which is what I'm describing as the gerontology approach, then bang, you're going to have a great result. You're going to postpone the age at which the damage reaches the amount that causes people to get sick. Fantastic. A couple of problems though. First problem is that you can't start when people are already sick, or even when people are in middle age, really, because then they've already got most of the damage that they're going to need to have to get sick. So slowing down the accumulation of more damage isn't going to help very much. You've got to start really early in life. That's a shame. But the other thing, which is even more of a problem, is this. Metabolism is just unbelievably complicated. Metabolism is so complicated that I can't even describe it. This here is, in fact, a simplified diagram of a small subset of what metabolism actually consists of. And, you know, anyone in the audience who had ever written software, you will immediately see that this is like the ultimate nightmare of uncommented spaghetti code. There is no way in the world that we're ever going to be able to tweak this system in order to stop it from doing the thing we don't want it to do, the creation of damage, without at the same time stopping it from doing things we need it to do to keep us alive. It's just not on. But luckily, that's not the end of the story, because there's a third approach that we can use that's much, much more promising. And that's the approach that I pursue, and that indeed Sense Research Foundation and many other people now pursue. I'm going to call it the maintenance approach. Equally, you could call it the damage repair approach or the engineering approach. Here what we do is we let metabolism generate damage at the normal rate, but we don't let it accumulate. We repair damage, we eliminate damage from the body every so often, not necessarily all the damage, but enough so as to keep pace with the rate at which metabolism is creating new damage. That way, the damage never gets to the point that is bad for us, that causes pathology. And this means that we don't have to understand. We can get away with not understanding the details of that horrible metabolic chart I showed you. If we're not proposing to interfere with metabolism itself, the creation of damage, it's okay that we don't understand it. And similarly, if we're not proposing to allow damage to reach the level that causes us to get sick, then we don't need to know much about the details of how damage does cause us to get sick when there's more of it than that. So it simplifies the problem of addressing aging with medicine to an enormous extent. And as I mentioned, that you know, aging is the same thing essentially in a human body as it is in a car. So have a look at this car. It is, of course, more than 100 years old, and it's working just as well as when it was built. And the reason it's doing so is precisely because of periodic, comprehensive, preventative maintenance. This car has benefited from having owners that looked after it well, and they took the trouble to remove the rust every so often before the doors fell off, you know, the pathology of cars. It's just the same. So, the only question I have not really answered yet is this one. Since the human body is so complicated, maybe the damage is really complicated as well, so complicated that even though the maintenance approach is the common sense one, maybe it's just, you know, impractical. But luckily that's not true. We can actually classify the types of damage that accumulate in the human body into a very manageable number of categories, just these 7 categories. And I've been listing these same 7 categories for 20 years now, so I'm pretty sure that this is a comprehensive list. Nobody has pointed out a number 8. Furthermore, other people have come up with the same idea. Here's a paper from a few years ago, which was the most highly cited paper in the whole of the biology of aging in the past decade. Actually, 3 of the authors were Spanish, out of the 5 authors. They divided aging into 9 categories instead of 7, but that's just a different way of doing the dividing. They didn't come up with anything that I had overlooked. Same idea, you know, divide and conquer. And in the laboratory, we ourselves at Sense Research Foundation have been able to make quite a lot of progress in developing medicines to repair most of these types of damage. Furthermore, people have started talking about it this way. The word rejuvenation has kind of become something over the years that was associated with cosmetics. But that's silly. It means making somebody younger again. And now it's being used that way. So I've got here the names of a couple of companies that came out of very prestigious universities, conferences, review papers. You know, this is now a very established word as well. Moreover, we've been able to move on to the private sector, the commercial world. So this is a list of companies that Sense Research Foundation has created. We ourselves at Sense Research Foundation, we are a non-profit, a charity, but it's much easier to get people to give you money if they have some expectation of eventually getting money back. So as soon as we get any project to a sufficient level of proof of concept that it can be invested in, then we make it a company, and sure enough, it gets more money. We've done that a lot now. Furthermore, it's not just us. This is a long, long list of companies that were created during the past few years independently of us, and they are all doing really well. They're getting a lot of money in the door. In fact, I can't keep this list up to date. Please take a note of the website at the bottom of the slide, because that's a website created by one of the most active investors in this field, and it has way over 100 companies listed. So this is really happening now. Damage repair is understood to be the way to go. We still have a role for the non-profit world, because there are still some projects which are not yet far enough along to be invested in, but we think that most of them are close to that point, so that they could even be in clinical trials by the end of next year. So now, what about longevity? I've told you I don't work on longevity, but I know that there are various policymakers in the audience, including decision makers, who care about this, who care about things like, how we'll pay pensions, how we will restructure society when people no longer die at a reliable, predictable age. And the thing is, it's going to be a while before these therapies come along. I've written up here my current prediction of how soon they're going to come along. Of course, we have no idea how long it's going to be, really, because it's pioneering technology. So it's a very speculative guess. But I think we have a 50% chance of getting there in 15 or 20 years. However, that actually means that we will actually have people living today who will probably live pretty much indefinitely, like to 1,000 years or more, simply because we will carry on staying one step ahead of the problem. The therapies that exist 15 or 20 years from now will not be perfect. They will probably only give people another 30 years of life. But those 30 years will be healthy years, and scientists will continue to improve the therapies thereafter. So I believe that people who are still healthy and alive in a good state of health at the time that these first therapies come along will probably never experience the health problems of late life. So finally, I just want to draw attention to the bottom line here. This is something that still seems like it's a long way away, maybe too far away for most politicians to care about it. But they'll sure as hell care when the general public starts to care. And I believe that the general public are going to start caring very soon, because they're going to know that this is coming. At the moment, most people still view this as more or less science fiction, but that's going to change. And when it does change, it's going to change very suddenly as a result of opinion formers like Oprah Winfrey saying things like that. So we'll see, but I think it's going to happen soon. I think politicians and policymakers have a real duty to be anticipating that right now. There are lots of reasons that people give today that are kind of excuses for aging, ways to pretend that aging is a blessing in disguise. They will say things like, oh dear, where will we put all the people? Or won't dictators live forever? And such like, or, how will we pay the pensions? But you can only really think that way if you put out of your mind the health issue, the fact that longevity is a side effect of health. And a world in which there are a lot more chronologically old people who were born a long time ago sounds scary, but it's only scary if we have a world that's full of biologically old people. And we're not going to have that. We're going to have a world in which there is basically nobody who is biologically old, and that's a much better world than today. So this is a book that I wrote about all of this some time ago. It was translated into Spanish a few years ago. El fin del envejecimiento, I think I have that right. However, Before I finish, as I mentioned at the beginning, I want to say a few words about the pandemic. First of all, of course, the pandemic is a terrible thing, and Spain is a particularly badly hit country. But once we bring this under control, what's going to happen next? I think it's almost certain that the general public will go back to living a pretty normal life and not thinking about their health any more than they do today. But policymakers and decision makers in all industries and in government and so on will not need to do that. They will be in a position, and indeed they will have a duty, to anticipate the next crisis, to think more rationally about health than we have in the past. First of all, I'm sure that policymakers will give a much greater priority to research and infrastructure that allows us to respond much more rapidly to future infections. There is a huge amount of research out there that should have been much better funded and would have put us in that position by now and saved a huge number of lives if policymakers had taken it seriously before. The second thing I want to say is the elderly are particularly important here. We all know that most infections are more dangerous for the elderly than for the young. Any seasonal flu that's true for them. Vaccines don't work so well for the elderly, but it seems to be particularly true for this pandemic, for this coronavirus, and that's going to be true in the future for some future infections. So again, it says there is research that we should be prioritizing. There has been a lot of progress in laboratories around the world in rejuvenating the immune systems of the elderly and getting the elderly to have immune systems that work as well as the young. But that research is still at an early stage, and it needs a lot more funding so that it can go faster, so that when the next pandemic happens, we will be able to keep the elderly alive and get them to recover from these infections just as well as if they were young. Finally, I think this should take us more generally to a point where we are more rational about health and where we understand that when we talk about research to bring aging in general under medical control, we should not simply react by saying, oh God, we shouldn't do that. Well, how would we pay the pensions? You know, we should remember that it's about health and that all age groups have a human right to the best healthcare that we can provide. At the moment, the elderly are the main sector of the population who get sick, not because of infections, but just because of the accumulation of damage in their bodies. And we have a duty to fix that, to develop ways to rejuvenate people and keep them biologically young, however long ago they were born. So I will stop there, and I would be delighted to answer any questions. All right, so Jose Cordero, who is a good friend of mine as it happens, unless it's a different one, he says, how do you see rejuvenation technologies in 5 years and in 10 years? How about reaching longevity escape velocity? Well, I think that within 5 years from now, most rejuvenation technologies, if not all, will be in clinical trials. And we will be seeing a lot of progress. We're already seeing progress in one or two of those technologies in the clinic, so that's wonderful. But the results that we will see in 5 years will be restricted to individual therapies. What will happen over the next 5 years, and probably the 5 years after that, is that these therapies will be combined to eliminate different types of damage in the same people. And that is what we will need in order to reach longevity escape velocity. I don't know, but my suspicion is that that's going to be a 10-year period, if not more. Because the fact is, when you put multiple medicines together, that's what happens. You get unforeseen interactions. So I think that we may get to longevity escape velocity in 10 years from now, as Ray Kurzweil suggests, but at the moment, my guess is it's more like 15 or 20. Sarah Mackenzie says, can I please elaborate on the duty to keep people biologically young? Well, I don't think it really needs any elaboration. What do we mean by biologically young? We mean not having the health problems of late life. And health problems of late life, no, people don't argue for them. People don't say that Alzheimer's is in some ways a good thing, or cancers, or heart disease, or osteoporosis, or anything. So I think the only way that anyone could have any doubts about duty to keep people biologically young is if they don't understand what biologically young actually means. Next question from Adam Long. Do I recommend NAD plus supplements or other interventions that young people can start now? No, I don't. In particular, first of all, I don't actually recommend supplements at all myself because I'm not an expert in that area. Secondly, I want to emphasize to people that everything we can do today, even the things that might be beneficial to us, will only be very slightly beneficial because we just can't manipulate our metabolism very well to stop us from creating damage. And thirdly, I want to point out that different people need different supplements because different people's metabolism are different. It's very hard to figure out what to do. So for young people, probably the best thing to do is to wait it out while people like me figure out more effective and safer therapies that are more predictably beneficial. And of course, what you can do as young people is to hasten this research. If you happen to be a wealthy young person, you can support it financially. If you happen to be a biologist, you can do the right kind of research. You can get into fields that are relevant to this area. If you're an aspiring politician, you can start making a difference in the corridors of power, and so on. Right, now the questions are beginning to, some of the questions are disappearing. So let me, oh, I see, somebody's saying answered. Okay, good. Someone says, I heard you once say people are too afraid of getting their hopes up. That's correct. It's not a question, it's correct. I think that's the main reason why people are willing to believe these crazy, stupid reasons why aging is some kind of blessing in disguise. Lisa Sullivan says, what do I see as the largest societal impact of an older population? Well, the largest one is that we will not have to spend so much of our time and effort and money looking after sick people because very few people will be sick. That's actually quite a big thing, right? So Julia writes, does the field need quick wins? Well, it will be nice. And certainly that's what we're going to get. We're going to have examples of rejuvenation therapies that only benefit some people, namely people who are particularly suffering from one aspect of aging, but they will benefit those people a lot. And that will be very conspicuous. So for example, the first application of therapies to eliminate senescent cells in the clinic was last year when Unity Biotechnology used senolytics on osteoarthritis. And it was just a very small trial, phase 1 trial, but it reported really good efficacy. In other words, people reported a greatly reduced level of pain, and that's what we want. If you see that in a big trial, it's huge. Craig writes, can we reconcile rejuvenation technology with ecological carrying capacity? Absolutely we can. It's an important question, but it's a question that's astonishing that people really even need to ask because the answer is so obvious. We are already working to increase the carrying capacity of the planet by developing renewable energy and artificial meat and desalination and plastic-eating bacteria, so as to reduce the amount of pollution in the planet that the average person generates. And if we do that, then we can increase the carrying capacity of the planet far more rapidly than the population of the planet would ever increase anytime in the next few centuries. So, it is completely ridiculous to say, oh dear, we should not keep people healthy when they are old, because they won't die and they will continue to generate carbon dioxide. That's just not the way to be thinking. Adam Long said, are there any countries or governments that are taking the challenge seriously? No, there are not, and I sure as hell wish there were. Actually, since I am addressing an audience in Europe, let me say a little more about that, because I think that the countries that may be inclined to take the challenge seriously first are the micronations, nations that have a very small population and very much more rapid decision-making processes than large countries with large bureaucracies, but yet they do have disproportionate influence in, for example, the European Union. So countries like Liechtenstein or Monaco or Andorra or San Marino. I actually am very pleased to say that I am in discussions with most of those countries to perhaps help them to take a lead in that space. And those discussions are taking place at a high level within government, which is definitely not happening for any other country yet. Letitia writes, do I believe that these technologies will be available for all people or only to rich people? Definitely for all people, and very quickly indeed, because those therapies will pay for themselves. It will be economically vital for any country to make sure that, even if it takes a lot of subsidy, that this happens. Because if not, then the country will have to look after sick people. And countries that do not have to look after sick people will be much wealthier. So someone else writes the same question, Vesa Ovinen, but actually this won't happen. It can't possibly happen. Of course, the reason people ask this question at all is because today, wealthy people do have better access to expensive high-tech medicine. But the reason they do is because that medicine doesn't work. And therefore, they stay alive, but they don't get healthy. And therefore, economically, it's not beneficial to the country to make them more available. Julia asked about cancer. Absolutely, cancer is part of aging, and it's something that we work on. Adam asks, is there any coordination at a global level? Well, kinda. Certainly, Sense Research Foundation has enormous influence around the world. We are based in California, and we fund mainly research in the US, but we promote research in other ways in other countries a lot. And I certainly believe that there is an enormous amount that needs to be done. What's happened? Oh, someone said that 11 questions have been answered. Let me check whether I believe that. And yeah, whoever's doing that seems to be getting it right. I believe I have answered all the questions that it says I've answered. If anyone has any more, I'm still here. What keeps you up at night? Yeah, funding is certainly an issue. It's less of an issue for technologies that have moved far enough along to be investable, to actually attract money, for-profit money, from high net worth individuals and from venture funds and so on. But there are quite a few technologies that have not reached that point, and that's why Sense Research Foundation still exists. And yes, funding is a huge issue for that. So I spend a hell of a lot of my time just trying to change that, to get people to provide philanthropic support for this work. And what keeps me up at night is the possibility that I'm not doing all I could for that, that I'm somehow making mistakes and not finding the best way to bring money in. What's Jose write? Oh yes, Jose writes a very important question. How can we use this pandemic to increase research on longevity? I'm not sure whether, I'm not sure whether this is going to work, but I think that one really important way to try to increase research on longevity is what I was trying to allude to at the end of my original talk, which is that the immune system, of course, is less effective in the elderly, and we're seeing that very conspicuously right now. But everything is less effective in the elderly. The immune system is just part of that, and all aspects of aging communicate with all other aspects. So if we really want to rejuvenate the immune system, there are things we can do that are direct. We can, regrow the thymus, or we can kill off senescent T cells, things like that. But really, that's only going to work well if we also rejuvenate the rest of the body. For example, it was recently shown that even if we have good T cells, then they don't really work because they don't behave correctly in lymph nodes, which are senescent and getting old and fibrotic. So we have to fix the lymph nodes as well. Tico writes, how do I think the increase of longevity will affect religious faith? Probably not very much, actually, because, you know, if we look back, you know, 200 years ago, people would have predicted that religious faith would be really badly damaged by the discovery that you know, humans did not come out of nothing. You know, and Darwin came along and explained where complex organisms came from, and here we are. And it seemed okay, right? So religion is fine still. There are plenty of other reasons to believe in God. So I think it's the same. You know, if we look at the way that this work is described in the media, as I mentioned earlier, people often use the word immortality, but that's nonsense, because people will, of course, still be perfectly subject to death, right? You know, and God can strike you down with a thunderbolt, however healthy you are. So if anything, it increases the motivation to live a good life and make sure that you do go to heaven when that happens. Julia says, do I look at blue zones? Yes, but not very much, actually. So there are quite a few people who study the biology of aging who do focus on blue zones. And the reason why, of course, is because we want to try to figure out why they live longer. But the problem is they don't actually live all that much longer. You know, maybe only 2 or 3 years longer than the immediately surrounding regions. So yeah, it would be nice to know, but the goal is to get them to live a lot longer than that. Plus also, it doesn't necessarily tell you how to get people to live longer with medicines or with lifestyle changes or anything starting late in life. Because these blue zones, of course, people who live there have mostly lived there since they were born. And it may be that the things that really matter for their exceptional longevity happened early in their lives.